How do we solve an equation that involves radicals? That's what we're going to look at here today. So a radical equation is an equation that has a variable under the radical sign. So that's the type of equation we want to investigate. So let's look into some of these. So if we have the square root of x equals 5, got to figure out what x is. Well, the key is we want to use inverse operations. So inverse operations are things like if we have x plus 5 equals 7, then the opposite of that is subtracting, and that's our inverse operation. If we have 5 times x equals 7, the inverse would be divided by 5, so on and so forth. All right? So what is the inverse or the opposite of square rooting? Well, that would be squaring, right? Opposite of squaring is square rooting and vice versa. So if we square both sides, we get 5 squared is 5 times 5, 25. That's it. And you can check it out by saying the square root of 25 equals 5. And that is true. Now, we are going to have to check our answers here. So that's going to be important with this operation, with these type of equations. So here we're going to square both sides. The opposite of squaring is square rooting, so these cancel each other out. So 2x plus 5 equals 144. And now it's all downhill from there, right? Just using the golden rule of solving equations. What is the golden rule? Do unto one side as you do to the other. It's good for life and it's good for equations. And we end up with a good old 139 halves. Fractions are fine. You can leave it just like that. And with radicals, again, we're going to want to check because strange things can happen here. We'll see. 139 halves. Does that equal, question mark, does that equal 12? Well, this is 2 times 139 halves is 139 plus 5 is 144. Is that really 12? Yes, it is. Okay, we can go one step further. 12 square root of 144 is 12, so yes, indeed, 12 equals 12. So now we want to look at situations where we got more going on. So here we have not just a radical, but we got this plus 5. So we've got to get that out of there first, all right? So let's get that out of there by subtracting. And so we have the square root of x plus 4 equals 8. And the opposite of squaring is the opposite of square rooting is squaring. So we're going to square both sides, so x plus 4 equals 64. All right. Subtract from both sides and we get 60. That looks like a good answer. So now let's check that out here. So we're going to plug in 60 for every x, which just shows up in one place here. All right. And we'll see if it comes out to be a true equation. Is that true? Well, there's the square root of 64 plus 5 equal to 13. And that's going to be 8 plus 5, which, yes, indeed, that is 13 on the left. And so 13 on the right. So that's equal. All right, so how about a cube root? Well, cube root we're going to treat the same way. So we want to get rid of that everything that's not under the radical. And so that 7 needs to go away. We've got a negative 3 over here. What's the opposite of cube rooting? Well, it's cubing. So we end up with x plus 3 equals negative 27. Remember, negative 3 cubed is negative 27. All right. So we end up with negative 30 So looks like we got an answer. Let's check it out. Is the cube root of negative 30 plus 3 equal to negative 3? Question mark. So that's the cube root of negative 27. And yes, indeed, we have negative 3 equals negative 3. So that checks out. Yep, we got it. So cube roots, square roots, isolate the radical, and square or cube or whatever the index is, use that power for both sides, okay? Raise both sides to that same power. All right, well, this is going to be an interesting one here. So if we have subtract 10 from both sides, and we end up with 2 square root of x equals negative 6. So now let's divide. So square root of x equals negative 3. Again, notice that where we are isolating the radical. We want to get that 10 out of there. We want to get that 2 out of there. Don't go squaring anything until that's all out of the picture. And now we've got to square both sides. And we end up with x equals 9. All right, looks like a good answer. Nice and simple. Now, let's check that out. Is 2 times the square root of 9 plus 10 equal to 4? Looks simple enough, right? So 2 times 3 plus 10. Okay, so that's 6 plus 10. And 6 plus 10 is 16. Is that equal to 4? No, it is not. Something happened here. Did we mess up on our algebra here? Nope. Did we copy it down wrong? Nope. Should probably check those things because that is possible. Okay. So 9 looks like it doesn't work. We could check our algebra. Did we do something wrong here? Nope, sure didn't. So we have to toss this out. This is what we call an extraneous solution. And what an extraneous solution means, you see the word extra there? It means it doesn't really work. It looks like it does, but it doesn't. So our technique will find solutions if there is one, but there isn't a solution here. So the answer is no solution. Or we can say the solution does not exist. Sometimes we'll say D and E for no solution. All right, so the solution doesn't exist. There's no number that will do that, no real number. And the reason is because, remember when we square root a number, when we square root 9, we get positive 3. Now, if we could get a negative 3 out of this, then this would work, right? Because this would be negative 6, and it would be all fine. But the square root here has to be positive. So since square roots come out to be positive, we can't get a solution out of this here. So a solution does not exist. Well, that's how we solve radical equations with just one radical there and only a variable under the radical. Next, we'll look into what happens if we have a variable outside the radical. What does that do?